Hello, today we are going to introduce how to set up iRTU with UpperLink Connection. In this section, you'll learn how to set up Modbus protocol. As we learn how to set up downlink with some protocol, you can learn how to set up UpperLink connection, that is, set up Modbus as a server. And also, we will introduce DMP3 and IEC104. For Modbus protocol, iRTU could play as Modbus server. You could open the connection of Modbus TCP and Modbus RTU depends on what the client wants. Check baud rate and data bit, and then add the text you want to provide to the client. AIO text has different data types to choose. For example, the address has default 3x0001 and you need to change it to 3x000 whatever based on your request, and so on. For the AO tag, default is 4x0001. Okay, you can change it to your request address. And also, in the DIO text type, user can set the DI has the default type address is 1x0001 and DO is ZX0001. And for the first step to do is adding text in Modbus server. Double click to edit the text list. Select the text you want to provide on the Modbus server for other Modbus client to acquire it. So double click and you can choose. And for example, you can use onboard DO 0. HLink will add an address for it according to the tag type and apply it. You can see the change. So if it is DO type, it will add it as 00012. The Modbus address will be added in a sequence based on your adding text sequence. So user may use ModScan to play as a Modbus client to get the onboard DO value. For example, if the internal address is 0012, would be Modbus address 0x0012, which needs to be set in Modbus client ModScan here. So after user set up the 00012 on ModScan, you can see if user change the onboard DO as 1, the ModScan could get the value also as 1. So here is the time for hands-on. User can use ModSim to play as a Modbus server and test as the topology. So ADEN3600 will acquire the text from the ModSim, which is a Modbus server, and then after it gets the data, ADEN3600 will be a Modbus server and acquired by another Modbus client, which is ModScan. So for the first step of the hands-on, please refer to this table to implement your ModSim address as the list. So please use your ADEN3600 as a Modbus client and the PC with a ModSim utility as a Modbus server. and then you add some text according to this requirement. And then, because we introduced in our previous chapter, here we provide some hints. User may need to set up the IP for MOSIM device. For example, 10.0.0.10 and port 502 for TCP, and give it a unit number. For example, give it 1, and you set up for the text. The result will be shown here. User could read the MOSIM tag in the EdgeLink Studio. Whenever you change your value in MOSIM, the corresponding value will be changed on the Modbus client ADEN3600 and will be shown here in the EdgeLink Studio. The hands-on for the Modbus server, which is our step 2. In this topology, user will need to change the protocol to upload. So you need to set up the ADEN3600 as a Modbus server. After change the protocol, user can support different kind of protocol up to the different cloud or server. But in this hands-on, we use the Modbus TCP. So you can view here your ADEN3600 is a gateway. And there are some requirements in this hands-on. Use ADEN3600 as a Modbus server. So you need to set up the address like this. And PC who play as a ModScan is a Modbus client. You need to apply for the change of setting up the Modbus server. If you follow our address rule, you will need to change the internal address in EdgeLink. So here are further settings. You need to set up the port and the maximum user and idle time. You could also change the data type here. And the result will be shown in your ModScan on your computer. So if you view the ModScan has got the corresponding value of EdgeLink, and it is success that you set up the Modbus server. And in this following section, you will learn how to set up DMP3 protocol. We will introduce the features and terminology. Also, we introduce DMP3 outstation configuration. We provide the hands-on with hands-on utility for you to get familiar with this protocol. So what is DMP protocol? It is represented as distributed network protocol. So you can view DMP3 as an improvement protocol for Modbus, because more and more devices require more requirement, especially in water and in electricity control company. DMP3 protocol provides a set of communication, and user can use between components in process automation system. It can be accessed through the wire to SCADA. In the drawing, RTU is as the gateway between the intelligent electronic devices and HMI SCADA. Here. Okay. And DMP3 has several features. The first is time synchronization. User can synchronize their device remotely. And second is sequence of event, SOE. It has timestamp variants of all point data objects with user-defined flag. Data acquisition methods with both direction, not only support data querying by master and also support data reporting spontaneously by slave. That is, the slave will actively upload to the master. And for the SSL encryption, which means the encryption and for the IoT application, which is very important for data security. DMP3 supports many types of data format. It can support floating point number, support different master data format. DMP3 calls it as variation. For example, format of 32-bit with flag, they call it as variation 1. And also, DMP3 supports P2P multiple peers and multiple addresses in one peer. We can see the architecture here. The master and slave architecture. Master inquire data by reading database from slave, also called as client. Slave allocates database. It can be set as event-oriented data reporting. It is also called as server. ADAM3600 supports 4 sessions as DMP3 slave. That is to say, master can inquire 4 different databases at the same time. To explain deeply, each session includes 1 slave ID and 1 master ID. However, ID can be set as the same number. For example, master ID 4 and master ID 4 in the same session. Then default is master ID is 3 and slave ID is 4. That is, slave is the server. So we use ADAM3600 as a DMP3 slave. Master would require the static different variations from the slave. And also, this iRTU can set up active upload. We choose event class 1, 2, 3 and deadband. If master doesn't choose one specific variation, user needs to set variation in HLink. So ADAM3600 can also play as DMP3 master, but we won't mention it in this slide. User may set up the data center, IoTech, TCP, and user can set up it as other devices. Some requirement and limitation here is that the version of HLink cannot lower than 2.1.1. Only above 2.1 we support DMP3. And limitation number 2, ADAM3600 has DMP3 supports only 4 sessions and for 4 master to connect it. So one master can use at most 4 sessions to connect. There are some prerequisites. we use the simulation software as on here. The utility, you can get it from the website. It is a freeware for multiple protocols. DMP3 master and slave or IEC104 master and slave simulator are all supported. So let us see how to set up DMP3 server in ADEN 3600 or EdgeLink. By double-click the DMP3 outstation, and user can use the default port as 20,000. Select the session and then enable this session. User may always need to remember enable it. And then slave address is for this iRTU device. Here is number 4. And master address is the maybe your simulation PC, and this is number 3. Set up the number of I/O tags you want to monitor. You can edit this number here, and below text list will change according to this number. In this demo, we use DO to control the tag values, so we use 4 tags of DO here. Select the I/O tags you want to monitor and press OK. Apply for the configuration changed and download it to the iRTU. The MP3 will run automatically after download. We could run freeware license version after installation. Using the freeware version may need to wait to start. After the waiting, user may see below image. So step 1 is simulate for the DMP3 master. Right click on the DMP3 icon in master zone and choose add DMP3. After adding the DMP3, a random given name will show up, and you could scroll down in prosperities. Added the link address as 3, which is your master, and slave address as 4. These need to coherent with your EdgeLink setup. For step 3, set up the DMP3 slave IP. Double click on the TCP in connections and edit the IP same as the IP of your iRTU device. Okay, so next step, run it by click check and then right click, select run. You can also edit the scan time here. The scan static. Okay, there are scan events and scan static. Find the loop scan tempo and edit it as 2000. Okay, because that is 2 seconds, 2000 milliseconds, which makes the master to inquire the data every 2 seconds. Okay, and then right click on the random name of DMP3 master and run it. After running it, user may switch to viewer to check the status. For the demonstration, to monitor the value, you may change the DO1 tag value manually from 0 to 1 in EdgeLink. After the value is changed, user may monitor the status of binary output status from false to true in viewer. Here, it becomes true. For more advanced parameters in DMP3, DMP3 setup, the group is defined for different data types. For example, group 1 is binary inputs, group 10 is binary outputs, and group 30 is analog inputs. EdgeLink has followed DMP3 definition for each group. User can view the configuration in more parameters in EdgeLink. Variation represents different data format in one group. For example, in group 30, variation 1 is defined as 32-bit with flag, this format, and variation 6 is another format, long floating point with 64-bit. So user can change their data type here in advanced parameters. The classes. DMP3 used the concept of classes to organize static data and events into several categories. For class 0, it represents static data. That is the present value. And class 1, 2, 3, user can define their own events, and it will store the value in this class 1, 2, 3. The points of most data type may be assigned to one of the 4 classes. If a point is assigned to class 0, the point's present value shall be reported by the outstation in its response to a class 0 poll. The master will use class 0 and get class 0 value. If a point is assigned to one of the event class 1 or 2 or 3, the outstation shall store the report events for that point, and the point's present value shall also be reported by the outstation when you use the class 0 poll. For example, if you want to monitor one specific analog input, you may classify it into class 1. As a result, whenever the master wants to get the specific data from analog input, it may pull from class 1 instead of pulling all data. If the master pulls data from class 3, as the above image showed, the data of running counters and frozen counters will be reported. So classifying the event data is one way to get the bandwidth efficient, and the slave would update a master each data, which we call as event poll. Setting the master to poll a slave frequently for a given amount of time, especially when the number of events generated in a slave is low. Using classes for events can make slave returns much less data than if the master had to retrieve all data on every poll cycle. So less is saving the bandwidth. Integrated poll. Integrated is a combined poll of class 0, 1, 2, 3. The setup of classes in slave can allow iRTU device be configured in different classes, which is called as unsolicited responses. There are several terms defined in DMP3, and we'd like to introduce it one by one. For data inquiry, there are two terms, static and event. So for the event, user can define the event as the measured value change, a measure whose value cross one threshold, and analog input changing by more than its deadband. There are two methods commonly used for detection of analog input events based on deadband. Fixed data deadband. If the absolute value of the difference between the present value of an analog input point and the value that was most recently queued as an event for that point exceeds the deadband value, then an event is generated for that point. To use active uploading, user needs to set up the text and assign event for them, class 1, 2, or 3. And user also need to set up the scan period. Here, okay, scan period for different binary input or binary output here. If the text is scanned have a different value change, and the class will upload all the data in the same class to the master. Moreover, event mode can be chosen as a sequence of events. Here, sequence of events of most recently or most recently. So if you choose sequence of events, all the text will be reported. Or user may only want to report the most recent value, which also saves the bandwidth because they don't care about the historical data. For advanced parameters here, time synchronization, which let the user to synchronize remotely by DMP3 master. Okay, this page we list out other reference data. You may see the FAQ, spec, and other testing tool here. In this session, you'll learn IEC104 protocol. We have introduction of this protocol, and we will introduce you the system architecture. And we also will teach you how to do the setup in EdgeLink, and also we use the Asian test and to give you a result. So let's take a look for the introduction. IEC 60870-5-104, also known as IEC 870-5-104, is an international standard released in 2000 years by the IEC, International Electrotechnical Commission. As can be seen from the standard's full designation network access for IEC 60870-5-101 using standard transport profiles. Its application layer is based on IEC 60870-5-101. So, IEC 104 enables communication between control station and substation via a standard TCP/IP network. The TCP protocol is used for connection-oriented secure data transformation. And IEC 104 limits the information types and configuration parameters defined in IEC 101, which means that not all functions available in IEC 101 are supported by IEC 104. For instance, IEC 104 does not support short timestamps. The length of the various address elements is set to defined maximum values. But in practice, vendors very often combine the IEC 101 application layer with IEC 104 transport profile without paying attention to these restrictions. This might then lead to problems if a device strictly applies the standard. So where to use this protocol? And it is widely used in control communication of water, gas, electricity, and needs SCADA telemetry control and information. The area which commonly used are in Europe and in China, the industry utilities, while the DMP3 is used in North America, Australia, and South Africa. So how could the user choose to use IEC 104 or DMP3? This is based on what SCADA they purchased and what protocol they supported. For the system structure with IEC 104, it is also a master-slave structure. So ADEN 3600 acts as an IEC 104 slave, which we know also as server, could be required by another IEC 104 master, which we also know as the client. So each channel includes one device address, and ADEN 3600 supports 4 channels as IEC 104 slave. How to set up? So the first step is double click in IEC 104 and enable the selection. User can configure 4 IEC 104 channels in total. The default port is 2404 and each channel needs to have a different port number. The default device address is 1 and set up the monitor text. There are 4 columns: DI, AI, counter, DO, AO. Please assign the AI text in AI column. The value type could be changed following your requirement. For example, floating point. And the setup for the action test is similar to DMP3. So user need to use the IEC 104 master and set up the IP of and the port of slave, and then set the monitor text. Please note that the unit here in IEC 104 is minute, so each 1 minute it will cyclic to acquire for the data. And there are more parameters we mentioned here. The public address, which is not used here, and the point number, public address, and the point number is the ID for recognition in master. SOE sequence of number. User can add timestamp of each tag. Use K value and base value to adjust the output range. For example, the output will be equal to K multiply X plus B. In this formula, user can adjust their output range. And changed %, which means the value change over the range only after this threshold, and it will be uploaded. For the SOE testing result, as you can see, if you choose the SOE here for the tag DI1, after the text upload, it will also combine with the timestamp. User can monitor with this information. For the AI value, there are support short floating point and normalized value and scaled value. As you can see, we just demo for these 4 different type, and the result are like this. For the control DO remotely in IEC master, you may see this command tool, and user may use the IOA as the point number, which user need to select. In this example, it is 2018. Okay, and then you key in this tool, select command, and then also send execute command. It will get the response of the required point number. That way you can control the DO command remotely. There are advanced settings here. Intuition is to use the usage of network bandwidth and then user can control it. IEC104 defines the number of APDU, Application Protocol Data Unit, which is you can see they are controlled by 2 values. One is K value, another is W value. K value means the maximum number that allows packets in sending state, and W value if non-ACK packets over W, it will stop sending packets. So with this mechanism, there are not so much packets on the transport. There are also some timeout settings. The T0 is the timeout of master to establish the session, so there is no need to set up here. And T1 is if there is no received ACK of sending messages after T1, we'll close the session. And T2 is the timeout of resending ACK after receiving information. And T3 is there if there is no more messages received after T3, slave will send a heartbeat message. So all this is to control the timeout. And we use this image to demonstrate more detailedly. For the T1 is the timeout of U frame or I frame. So we said in our previous slides, T1 means the time to wait ACK, to a transmitted APDU. In this time expires, the master assumes data has been lost and attempts to retransmit. So here the master and the slave, it means the master will send U frame, that is a test TFR act, and slave is the U frame test TFR count. There are also some I frame and S frame. So the T1 here, the timeout is after the sending. Okay, it will do the close. If there is no ACK, it will be timeout. Okay. The T2 is the resending ACK for the I frame. I frame means the information frame. So if there is a lot of I frame, and it will count for the T2 timeout, and only after the T2 timeout, the master will reply S frame after receiving W I frame. So T2 means the time to wait before sending a supervisory APDU ACK. Increasing this setting can reduce bandwidth required for acknowledging. So if you increase T2, it will just get longer time to send the ACK package. And that also save the bandwidth. Slave means the iRTU sends at most K iframe. Master would reply S frame at receive W iframe or after T2 timeout. And T3 means the sending test frames for the heartbeat. So they use the U frame to do the handshake for establishing session. Master and slave, they will send this heartbeat for every T3 seconds. So once you see, okay, there is no information, there will no packet transported. After T3 timeout, they will send a tester for acting, checking the session is still established. To control the usage of network bandwidth, IEC 104 defines this whitelist for IEC master to control DO and AO. So user can set up this IP and edit for their IP whitelist access control right. This would improve their security. Thank you for listening.